Hey guys, today we're going to talk about deductive reasoning. This is section 3 of your second unit. And I first want you to start off with the definition for deductive reasoning. Okay, write this down. Deductive reasoning is the process of using logic to draw conclusions from given facts, definitions, and properties. Okay, so if you have a situation where they give you facts, definitions, or properties to solve a problem or an issue, then you're using deductive reasoning. Okay, so let's go through a couple of different examples and decide if we're using inductive reasoning that we learned last time, or if we're using deductive. Okay, so example 1 says there is a myth that you can balance an egg on its end only on the spring equinox. A person who is able to balance an egg on July 8th, September 21st, and December 19th. Therefore, the myth is false. Okay, so when you're reading this, of course, you don't have any facts, you don't have any definitions, you don't have any properties, you kind of just have hearsay. Okay, so this is not deductive. This, my friends, would be inductive. Okay, to be deductive, you have to have facts, definitions, or properties. Okay, let's try another. Alright. Second one, it says there is a myth that the Great Wall of China is the only man-made object visible from the moon. The Great Wall is barely visible in photographs taken from 180 miles above Earth. The moon is about 237,000 miles from Earth. Therefore, the myth cannot be true. Well, you're given some facts on this one. You're given that there are photographs 180 miles from Earth. You're given that the moon is 237,000 miles from Earth. Okay, so since you're given facts, this would be deductive. Okay, let's try one more. This one says, there's a myth that an eelskin wallet will demagnetize credit cards because the skin of the electric eels used to make the wallet holds an electric charge. However, eelskin products are not made from electric eels. Therefore, the myth cannot be true. Alright, once again, we have definitions and we have facts. Okay, so it says the skin of the electric eels used to make the wallet hold an electric charge. Okay, that gives us a fact. And once again, we have another fact that says eel skin products are not made from electric eels. So since we are given facts and properties about the wallet, this in fact is deductive. Okay, so go through those three again. If you need to re-listen, that is fine. Alright, in this section we need to learn several different properties, and the first one is called the law of detachment. Okay, and the law of detachment is a form of deductive reasoning, and what it says is that if you have P going to Q, if P going to Q is a true statement and P is true, then Q must be true. Okay, so once again, if you have P going to Q being true and P is true, then of course Q is true. And this is called the law of detachment. These are one of those properties that you need to memorize. Okay, so we have some examples here, and we want to decide if the different examples are true by the law of detachment. Okay, so it says that you're given in the World Series, if a team wins 4 games, then the team wins the series. Okay, so that's what we're given. And our situation says the Red Sox won 4 games in the 2004 World Series. Okay, well, if we know that if P is true, then Q is true. Okay, so since the Red Sox won 4 games in the World Series, and our conjecture is that the Red Sox won the 2004 World Series, this, of course, is valid by the law of detachment. Okay, so this one would be valid. Okay, if P, then Q. We know P is true, so Q is true. Let's try another one real quick. Example 5 says, if the side lengths of a triangle are 5, 12, 13 centimeters, then the area of the triangle is 30 centimeters. And our situation says the area of PQR is 30 centimeters squared, and that our conjecture is that 5, 12, and 13 centimeter sides give us an area of 30. Okay, and while that may be, obviously there could be any number of different side lengths that could get us an area of 30. Okay, so since the dimensions could be different but still produce an area of 30 centimeters, this one is going to be not valid. Okay, you could produce multiple different side lengths that give you a different area, so that one is not going to be valid. Okay, one more for law of detachment. This one says, if a student passes his classes, the student is eligible to play sports. Okay, so since Ramon passed his classes, Ramon is eligible to play sports. Well, since the first thing is true, then the second thing must follow. Okay, so since Ramon passes classes, he obviously can play sports. So this one is, of course, valid. Okay, next law for you. Okay, and this one's kind of goofy. Okay, it's called the law of syllogism. Okay, and it says if P goes to Q and Q goes to R are true statements, then P goes to R as a true statement. So let me give you an example of the law of syllogism, how it would work. Okay, so let's say you had the situation, if it snows today, then I will wear my gloves. Okay, so that's your first statement. If it snows today, then I will wear my gloves. Okay, and then you have a second statement. If I wear my gloves, my fingers will get itchy. Okay, so then you can have three different statements. One, if it snows today, then I will wear my gloves. Or two statements. And then if I wear my gloves, my fingers will get itchy. So you can deduce, if it snows today, well, my fingers are going to get itchy because when it snows, I'm going to wear my gloves, and when I wear my gloves, my fingers will get itchy. And so that's just one example of that. All right, let's go through a couple of these and determine if they are valid or not. Okay, so the first one says, if a figure is a kite, then it is a quadrilateral. If a figure is a quadrilateral, then it is a polygon. And the conjecture is, if a figure is a kite, then it is a polygon. Okay, so let's go ahead and figure out which part is which. Okay, which part is P, which part is Q, and which part is R. Okay, so our P, of course, is going to be if a figure is a kite. Okay, so that would be our P. Our Q, or that was our hypothesis. Our conclusion would be if a figure is a quadrilateral, okay, then our R would be it's a polygon. Okay, so let's go ahead then and go ahead and look at this. Okay, so if you have P going to Q, meaning if you have a kite, the figure is a quadrilateral, and that is for sure. Okay, and then you can look at Q going to R. Okay, and since if you have a quadrilateral, it is a polygon, and that is true. So since you have those two things are true, you can go ahead and deduce that P also going to R is also a true statement. Okay, so this would be a valid statement. Okay, a couple more. Alright, this one says, if a number is divisible by 2, then it is even. If a number is even, then it is an integer. Okay, so your conjecture is if a number is an integer, then it is divisible by 2. Okay, so let's go ahead and determine our different pieces again. Okay, so our hypothesis, if a number is divisible by 2, it's our P. And then it is even is going to be our Q. And our R is going to be it is an integer. Okay, so if you look through this, okay, so let's look at this real quick. If you have P going to Q, you're saying that if a number is divisible by 2, then it is even, which would be true. So P would go to Q. And let's look at Q going to R. Okay, so it says if a number is even, that it is an integer. Okay, but let's go ahead and look at going from R to P. You would read, if a number is an integer, then it is divisible by 2. Well, that isn't true. You could have a lot of different integers that aren't divisible by 2. And so this one's not going to work out. It's not valid. Alright, let's look at our last example. It says if an animal is a mammal, okay, so that's your P, then it has hair, would be your Q. And if an animal is a dog, that'd be your R, then it is a mammal. That leads back to your P. Okay, so if you look at it, P going to Q. If an animal is a mammal, then it has hair. Okay, that's reasonable. And if an animal is a dog, if an animal is a dog, then it is a mammal. Sounds good. So, if you are a dog, then you have hair. Okay, and all of that obviously is true. Okay, so this thing is going to be a valid statement. Alright, let's look at our last example here. And you're going to have to think a little bit on this one. It says, if 2y equals 4, then z equals minus 1. And if x plus 3 equals 12, then 2y equals 4. And it says x plus 3 does in fact equal 12. So since x plus 3 equals 12, we now know that 2y equals 4. And since 2y equals 4, we then can deduce that z equals negative 1. Okay, so the result that we draw from this given information is that z equals negative 1. Okay, so sometimes you're going to just have to read them carefully, try to see what it's wanting from you. Letter B. It says if the sum of the measures of two angles is 180 degrees, then the angles are supplementary. If two angles are supplementary, they are not angles of a triangle. Okay, so if measure angle A equals 135 degrees and measure angle B equals 45 degrees, we're supposed to come up with something or draw a conclusion from the information. Okay, so since 135 degrees plus 45 degrees equals 180, well, we know since those add up to 180, it can't be a triangle. Okay, so angle A and angle B are not angles of a triangle. Okay, so angle A and angle B are not angles of a triangle. Okay, I would like you to look at the lesson quiz by yourself. There's a few questions there for you. Okay, so look at these 3 different questions here. Go ahead and answer those on your page, and then we will get some homework time. See ya.